In this video, let's talk about attitude towards risk. In the earlier video, I explained you the difference between expected value and expected utility. Okay, so let us see how an individual decides when he is facing risks. Okay, so what is meant by risk? Risk is actually the possibility of facing a misfortune or a loss. Okay, suppose we have an individual. Okay, we have this very individual. He is facing two choices: choice A and choice B. Okay, in choice A, he is being offered a lottery. Okay, in choice B, he is being offered a certain amount. Okay, so the lottery is like this: there is 50% chance that he will win $100 and 50% chance that he will earn nothing or $0. Okay, and in choice B, he is being given the expected value of this lottery. Okay, I explained you the expected value. How do we calculate the expected value? When we multiply the random outcomes with their associated probabilities and sum them up, we get expected value. In this case, expected value is 100 into 0.5 plus 0 into 0.5, which is equal to 50. Okay, so we have a person, two choices A and B. In choice A, he has to play this lottery, and in second choice, he is being assured a certain amount of $50. Okay, now we need to see how do the persons take the attitude towards the risk. Okay, so let's take a person A. Okay, who is a risk averse. Okay, a person is said to be risk averse if, okay, if the utility of expected value is greater than the expected utility of lottery. In this case, okay, by risk averse we mean a person who does not like taking risks. Okay, for a risk loving person, the utility of expected value is less than the expected utility of lottery. And for a risk neutral, he is a person, okay, who is indifferent between uh, playing this choice A or playing this choice B. Okay, where the utility of expected value is equal to the expected utility of lottery. But what is this utility of expected value? It simply means utility of certain amount, assured amount. If it is greater than the expected utility of lottery, the person is said to be risk averse. Okay, so we can write it like this. So utility of, what is expected value? This is 50. Okay, let me write it here. Utility of getting certain amount, that is equal to 50, if it comes out to be greater than the expected utility of lottery. What is the expected utility of lottery? It is simply 0.5 into utility of $100 plus, let me write it here, plus 0.5 the utility of $0. Okay, so if the utility of certain amount is greater than the expected utility of lottery, we say the person is risk averse. Okay, so how can we define the risk averse person? We need a utility function. Okay, for a risk averse person, the utility function is like this: u of x is equal to under root of x. Okay, so this very utility function denotes a risk aversion situation. Okay, so let's take to calculate what does this simply mean. So what is the utility of $50? Okay, let me write it here. Utility of $50 is equal to, so we have this under root here, let me write it here. Utility of $50 comes out to be 7.09, which is this very thing, utility of, what we call a utility of expected value. Okay, and what is the expected utility of lottery? Okay, expected utility of lottery, that means will be equal to 0.5. We are just plugging this utility function in this. Okay, so what is the utility of 100? That means under root of 100. Okay, I hope I am making myself clear. Plus 0.5 the utility of 0, that means under root of 0. Okay, when we solve this, it comes out to be 5. Okay, I hope I make myself clear. Now how What does this mean graphically? So we can show it graphically here. Let me draw the graph here. So we have graph like this. So we have a under root function. So how does this look? It looks like this. Okay, so it is concave shaped. Okay, why is this concave shaped? This very thing. First the slope increases, and after then the slope of this function decreases. Okay, so you know it by graphically. Here we measure the payoff. Okay, payoff, and here we measure the utility. Now what is the what we call, what is the utility of $100? Utility of $100 comes out to be, if we so let me first write it like this. We have 0.5 under root of 100 is equal to 10, plus 0.5 under root of 0 is 0, which comes out to be 5. Okay, now what is the utility of $100? Is it comes out to be 10. Okay, so I can write it like this. So we have $100 here. So the utility of $100 is equal to 10. And what is the utility of $0? Here we have 0. The utility of $0 is 0. Okay, how do we find the expected utility? Okay, so expected utility is simply found out by when we join these 2 pointers. Okay, and draw a line like this. Okay, then we find the mean of this line. Okay, how do we find the mean of this line? We have this 0 here. Okay, when we multiply, this is 1/2 of 0 plus 1/2 of 100. Okay, so this comes out to be 50. So we have here 50. Let me write it like this. We have here 50. Okay, now utility of expected utility comes out to be, when we join these two, here also we have 1/2 of 10, 1/2 of 10 plus 1/2 of 0. Okay, so this comes out to be 5, and this 5 denotes the, what we call, this point denotes as the expected utility of lottery. And what is the utility of expected value, which is this very thing, utility of certain amount? It comes out to be 7.09. Okay, so if we join here, so this is 7.09. Okay, so this is our utility of expected value, utility of expected value. Okay, what we call utility of certain amount. When here we can easily see utility of expected value, this is 7.07, is greater than this expected utility of lottery. So we say that very person is a risk averse person. Okay, I hope how you know how I calculated this. We just take the mean of this line, okay, according to their probabilities. Okay, and this denotes the utility of $50. Okay, utility, this is also the expected utility, sorry, what we call here, the utility of expected, sorry, utility of $50 came out to be 7.09. That means utility of certain amount is 7.09, and expected utility of lottery came out to be 5. So this denotes the lottery, this denotes the certain amount. Okay, when the utility of certain amount is greater than the expected utility of lottery, we say the person is a risk averse person. Okay, so why this concavity is actually, it simply means slope is decreasing, which in turn implies that individual exhibits the diminishing marginal utility for additional units of payoff. Okay, so in this case we have diminishing marginal utility. Okay, in other words, the risk averse consumer or agent is not willing to take or to incur additional risk for possibility of higher valued payoff. Okay, so this is for a risk averse person. Okay, how is the risk loving person defined? Okay, for that we also need a utility function for that. Okay, so for a risk loving person, we should have utility of getting $50, that is certain amount. It should be then less than the expected utility of lottery. Okay, so this is 0.5 utility of $100 plus 0.5 into utility of $0. Okay, so for that we also need to define the utility function for what we call, for a risk loving person, utility function is defined like this: ux is equal to x square. Okay, so this is the utility, what we call utility function for a risk loving person, a person who loves to take risk. And how do we see this? Let's take the graph of this very also. So can I draw the graph here? I guess I should be able to draw the graph here. Okay, let me draw the graph. For a risk loving person, we have this x square function, so this will be looking like this. Okay, for a risk loving person, we have increasing marginal utility for payoff addition. Now, what is the utility of certain amount? Certain amount, that means utility of $50, this expected value. So this will come out to be 50 square, that comes out to be 2500. Okay, and what is the expected utility of lottery? So expected utility of lottery, let me write it like this, will come out to be, we just need to plug, we have 0.5, the utility of $100, that means plugging this x, so we have 100 square plus 0.5 into 0 square. Okay, this comes out to be 0.5 into 100 square comes out to be 10,000. Okay, we have 10,000 plus 0.5, 0.5, 0 square, this comes out to be 0. Okay, so what is the utility of $100? So let me write it here. Utility of $100 came out to be 10,000, so we have here 10,000. And what is the utility of $0? Okay, so we have 0 here, so utility of $0 came out to be 0. Okay, now we need to find out what we call the expected utility of lottery. How do we find the expected utility of lottery? We join these two pointers. Okay, and take the mean of this line. Okay, how do we take the mean of this line? Simply on the horizontal axis, we take this 100 and multiply it with the probability, this is 1/2, and here we also multiply it with the corresponding probability. Okay, and then uh, take the average of these two, and it will come out to be 50, obviously. Okay, let me write it like this. So this is here 50. Similarly, here we take the probability, that is 1/2 of 1000. Okay, I'm just trying to explain how do we take the mean of this function here, into 1/2 of 10,000 plus 1/2 of $0 divided by 2. Okay, and this will come out to be, we have 10,000, it will come out to be 5,000. Okay, obviously it will come out to be 5,000, so let me write it like this. We have 5,000 here, so this 5,000 here denotes the expected utility of lottery. Okay, and what is the utility of certain amount? Utility of certain amount we have calculated, that came out to be 2,500. So this point. Okay, so we have 2,500 here. So this point, this denotes the expected utility of lottery, and this point denotes the utility of certain amount, what we call the expected value. utility of certain amount comes out to be this, and expected utility of lottery came out to be 5,000. Okay, so here if we calculate this very thing, and this very thing is this will come out to be 5,000. Okay, 5,000, that means expected utility came out to be 5,000 and utility of certain amount came out to be 2,500. In this case we say, since utility of expected value is less than expected utility of lottery, we say this person is loving one. Okay, this person loves to take a risk. Okay, so why is this convex shaped? Okay, now this curve, as you can see, it becomes steeper and steeper as the agent's payoff increases. Okay, hence risk preferring agent has increasing marginal utility for additional units of payoff. Okay, so we have increasing marginal utility for additional payoff. Here we have decreasing marginal utility for additional payoff. Okay, so what we can also say that it implies that risk preferring individual is quite willing to take additional risk for the possibility of higher valued payoff. Okay, so this was the risk loving person, where the expect utility of the certain amount is less than the expected utility of lottery in this case. Now coming to the risk neutral person, a risk neutral person is indifferent between the utility of certain value, certain amount he is getting, and the expected utility of lottery. Okay, so he is indifferent between choice A and choice B. For that, let us say utility of $50, as we have calculated, should be equal to the expected utility, that means 0.5 into utility of $100. Okay, plus 0.5 into utility of $0. Okay, so for that also we need to define the utility function. For a risk loving person, the what we call the utility function will be a I will not say linear one, it will be like this. Utility of x is equal to x upon 10. Let us have this very function for, rather the utility function for a risk neutral person. Okay, so now let's draw the graph for this person also. How does the graph look? So let's draw the graph here. So we have payoff here, payoff, we have utility here. Okay, now what is the utility of certain amount? So let me write here. Okay, this very thing, utility of $50, that is the utility of expected value will be equal to, so plugging this equation, so we have 50 upon 10, which comes out to be 5. Okay, what is the expected utility of lottery? Expected utility of lottery will be equal to 0.5 into utility of $100, that means plugging this equation, so we have in place of x we have 100 upon 10 plus in place of this, then we have 0.5 into utility of 0, that means 0 upon 10, we have 0 upon 10 when we solve this further. Okay, so so this is like this, so this is 0.5 we have into 10 plus 0.5 into 0. Okay, so let's define the graph for this very person. It will look like this. Utility of $100 which we calculated, it came out to be 10. Okay, so we can write it like this. This is $100, it came out to be 10. Okay, and utility of $0, obviously it came out to be 0. Now we need to take the mean value of this line. Okay, so this came out to be, we calculated, this will come out to be 5 also. Okay, so we have here 5. Okay, and here we have, how do we get this very point? This is utility of $50. Okay, so this is $50. This denotes this point, sorry, this 5 denotes actually we have utility of certain amount, what we call utility of expected value is actually equal to expected utility of lottery. Okay, simply both these two lines actually overlap in this case, in a case of risk neutral person. Okay, I hope I make myself clear in this video. If you like these videos, please share, subscribe, and comment also. Okay, I will like to take your feedback, whatever it is. Okay, so I just make these videos for free. I don't have any interest of making videos if you cannot respond. Okay, so if you respond, then I will make other videos on what we call the choice under uncertainty. Thank you.